Welcome back to our biomass class, where we're delving deeper into the fascinating world of conversion of biomass resources into heat and power. This video was made with the support of Energy. After the analysis of project stakeholders, let's focus now on the calculation of the energy demand. When sizing an energy supply solution, the first and foremost design parameter to determine is the expected demand, specifically the heat demand and the electricity demand. Heating demand is broadly divided into low temperature demand for space and water heating, and high temperature demand for process heat in industry. This video is about low temperature demand for space heating and domestic hot water, or DHW. For the heat demand in buildings, the questions we will address are: how can we estimate the heat consumption for a given service that includes private houses and public buildings? How does the heat consumption change along the day and along the year? How can we calculate the energy to be provided and the power to be installed? Obviously, there are different approaches. Let's start with the calculation of the heat consumption. The first decision you must make is the accuracy you need for your project. The higher the accuracy, the greater the difficulty of the calculations. When sizing the heating system, the goal is to supply all the energy that is needed when needed. Then, you may be tempted to oversize the system. The bigger the better. However, you should keep in mind that oversizing heat sources decreases the efficiency and the economic viability of heating systems. Therefore, you need a certain degree of accuracy to ensure the realisticness of your design. Ideally, a site's heat demand profile should explore: first, the different grades of heat used. For example, the expected outdoor and indoor temperature differences variations during the year. This may also include a cooling demand. Second, the daily variation in heat demand with at least hourly resolution. This is helpful to identify the peak heat power demand over a daily cycle. And, finally, the seasonal variations such as for space heating along 1 year period. Okay, but, on what parameters does the heat demand depend? Let's differentiate between space heating and domestic hot water. Space heating strongly depends on the outdoor temperature. It is not the same to size a space heating system in Stockholm, Paris, or Barcelona. Therefore, a first input for your calculations are the local climate conditions. Another important parameter is the use given to the building. For example, a single-family house, an apartment block, a school, an office or an office building, a hospital, or a sports center. You can find information in internet like the Entrance project with calculations of different building types in different European locations. For domestic hot water, the consumption of domestic hot water depends on the utilization given to the building and can be different for different countries. It also depends on the monthly temperature of the external environment. You can find data in internet like the Entrance project, like the consumption per square foot for different types of buildings, or the average consumption per occupant in different countries. You can use national regulations and standards that set the liters of hot water per person and day for different types of buildings. In Spain, you can use the technical code for edification. In the EU, you can use the standard EN 15316-3-1. Let's move to the next question. How changes the heat consumption along the day and along the year? The first step is to understand that heat demand changes continuously. Then, it is not enough to calculate the overall energy consumed during a year to size boilers and heating systems. As said before, energy demand depends on climate conditions. Therefore, monthly thermal demand for space heating or cooling will change depending on these conditions. Changes in domestic hot water can remain almost constant over the year. And regarding hourly consumption, It additionally depends on the utilization of the building during the day for both space heating and domestic hot water. From these data, peaks and daily demand are used to size boilers and storage systems. Let's move to the next question. How can we calculate the energy to be provided and the power to be installed? Let's start with an already existing building. For example, if you want to switch an already existing facility consuming fossil fuels to renewable resources like biomass, you can use existing fuel consumptions from recorded data. For example, data of natural gas consumption is available for a public building. You need to convert the cubic meters of natural gas into energy by multiplying the gas volume by its heating value. This is the energy input. To convert this input into energy delivered and really consumed in the building, you need to multiply by the boiler efficiency, for example, 90%. If metered data for the site is available, then hourly, daily, or monthly load profiles can be constructed showing variation in load over time. If data are available, not for a single building, but for a district heating, several efficiencies of the devices involved in the network must be assumed. 60% for the building heat exchanger, 95% for the district heating network, 90% for the boiler. For new projects, we don't have records. Therefore, we need to calculate the heat demand. As said before, domestic hot water demand can be calculated using standards and codes. So, let's focus on space heating. Calculations are based in the analysis of thermal loads. Their components are the sensible heat flux, the ventilation transmission, and the sun heat flux. The sun heats the walls and ceiling, also the indoor space through the windows. The sensible heat flux is the heat transfer due to the difference of temperature between the building and the outdoor environment. It can be calculated by multiplying the indoor-outdoor temperature difference by the building envelope surfaces and the global transmittance factor. For more accurate calculations, different transmittances can be defined for each type of surface. For example, walls, windows, ceilings, and so on. Finally, the ventilation thermal load is due to the proper flow rate of fresh air needed to maintain the indoor air quality. Calculations can be done using standards like the EN 13790. It is based on the volume of air required per hour for each room. Doing all these calculations by hand is very tedious. Therefore, software tools can help you to do calculations in a more accurate, complete, faster, and friendly way. Energy Plus is one of the most used and reliable programs for energy analysis and thermal load simulation. Energy Plus is free, open source, and cross-platform. Its development is funded by the U.S. Department of Energy. Clima is a free software in Spanish developed by the Technical University of Valencia. Wrapping up. The typical heat demands of a building are: supply of domestic hot water, space heating or cooling. Domestic hot water needs can be set from national or international standards and codes. Its demand changes from country to country and depends on the building utilization. Space heating depends on local climate conditions, building design and orientation, building utilization. The heat demand changes monthly along the year, hourly along the day. Calculating heat demand curves is essential to calculate the year consumption, to calculate peaks of demand, to size heating equipment and storage systems. Free software tools are available for performing these calculations in a complete, accurate, and user-friendly way.